So hello everyone. So now we're going to start with our next thing, which is just application of differentiation. So till now we have studied first derivative, second derivative, right? And we have seen the maxima minima. And now we are going to see what is the application, what is the real life application of differentiation. Okay, how to apply that in real life. Okay. So if you have y equal to a into b, okay, and you want to maximize the y where it is given that a plus b equal to 40. So if you're, let's say, if you take, and what is happening here is, if you take a as 40, then b is 0, so y is going to be 0, right? A into b. But if you take a as 30 and b as 10, right, so y is going to be 30 into 10, so that is 300, right? So like that, if you change the values, it's gonna change, right? So what is the maximum value of y? Okay, now I want to maximize y. Okay, so the first condition is the whatever you are going to maximize, that should be in one variable. Like, but here what is happening is a is also changing and correspondingly b is also changing. So I have to find out the other relation between a and b to eliminate one variable. So what I saw here is we have the other relation. Okay, so I will put this value here. What I got, y equal to a into 40 minus a, right? B from here is 40 minus a. So what I got, y equal to 40a minus a square. Okay, now you have to maximize the value of y, okay, for a particular a. Okay, so how you will maximize? You will do first differentiation, dy by dA. Okay, that is 40 minus 2a, right? This is your first derivative, and it for the maxima and minima it should be 0, right? So a equal to 20, and you can say for d2y by dx square, d2y by dA square is also minus 2, so this is less than negative, so less than 0. So I can say a equal to 20 is the maximum value. Okay, so I can say a equal to 20 at a equal to 20, y is maximum. Okay, so what is the y maximum at that particular point? So I can say 20 into b is also 20, right? So that is 400. So maximum value of y that is possible is 400. Okay, where a and b both will be equal and they will be 20. Okay, so this is how we calculate. How we did this question? You see the pattern. What is the pattern? We want to maximize a function who have two variables, a and b. Okay, so what I will do, I will just remove one variable and make this whole equation in one variable. So I eliminated the b and I did whole equation in one variable, that is a, and then after I maximize that function. Okay, that's all. Now let's see next question. Okay, next question I have is the area of the circle is related to the radius as pi r square. We also know. Okay, how fast area changing with respect to time when rate of change of radius is 4 centimeter and radius is 2 centimeter. So we have area equal to pi r square, and he is asking rate of change of area. So means he is asking dA by dt. At what point? At, he is asking this at what? dr by dt is 4 centimeter per second and r equal to 2 centimeter. These are the values at that particular point. His dA by dt is asking. So what I saw here is I can differentiate this a with respect to time. So if I differentiate, so this is the way only I will get dA by dt, right? So I differentiate with respect to time. Pi is constant, r square I will differentiate. So first power differentiation, that is 2r into then r differentiation with respect to time. So this will be dr by dt. Okay, simple. Okay, so dA by dt I want to calculate. Okay, so pi into 2 into r value 2, at r equal to 2 only I want to calculate, and dr by dt will be 4. Okay, so this came how much? 4 for the 16 pi centimeter square per second. Okay, this is the rate of change of area. Okay, so this is only he asked me. Okay, now let's go to next question. Okay, so he is asking here a sheet of area 40 meter square is used to make an open tank with a square base, then find the dimension of the base such that the volume of this tank is maximum. Okay, so you are making a square open tank. So this is A, this is also A, and this height is also A. Okay, and I'm saying this is open from above. Okay, so you don't assume this is closed, just this is just a diagram, simple diagram. So we can say this is open. Okay, from above it is open. Okay, just you see here. Okay, this is open. Okay, so what is the question is, from a sheet we purchased a sheet of 40 meter square. Okay, and then we are using that sheet to make a tank. Okay, with A as the dimension. Okay, so how many sides we use, how many sides we will use? We will draw this four sides plus base 5 sides. Okay, so the 40 meter per square, that area, what I am using that area in is basically A square into, let's say this is not a square base, right? So height can be anything, so I am assuming this as h. Okay, height can be other thing also, it is not equal to A. Okay, and the square is the base is square, so base height and width are same. Okay, the base length and width are same, and height is h. Okay, so what is the area that I want to maximum? That is A square. Okay, plus what can I say, this will be A into h, how many times? 4, so 4AH. This is what I want to maximize, right? So I hope this equation you understood, right? So for 40 meter square area I am making one square base and 4 sides of this tank. Okay, by this. Okay, now what I want to maximize? I want to maximize the volume. So volume of this tank is how much? Tell me. A square into h, right? Now as the same as previous question, you can see, same as previous question, what you can see here is, here I wanted to maximize y, and A and B we had two variables. Okay, similarly we have here that I want to maximize v, but we have A and h two variables. Okay, so I will eliminate one variable. So from the first equation which we have, from here I will calculate the value of h and I will substitute in this equation. So h will eliminate and whole volume will come in terms of A. So A square and h. So from h, if you calculate here, you will get 40 minus A square divided by 4A. Okay, this is what you're gonna get. So volume you will have, what you're gonna get here, we will have volume equal to 10A minus A cube by 4. Okay, so if you differentiate dV by dA, okay, for maxima and minima, what you will get, 10 minus 3A square by 4. Okay, this is what you get. So for maxima minima you will put dV by dA equal to 0. So if you put this dV by dA equal to 0, you will get 10 minus 3A square by 4. Okay, so what can I say? A equals to, obviously here you will get A equal to plus minus under root 40 by 3, but we will only accept A equal to positive value because this is the side of triangle. Okay, side of this is the length, right? So length is always positive, so we're going to accept positive thing. Okay, so now we want to find out what volume of the tank, maximum volume. So okay, so we know the volume now. Come back, so V is maximum, so V equal to A square h, where we calculated the A value 40 by 3, under root of 40 by 3, right? Let's put this value, okay, and what you got, y. So you can calculate the value of y, right? So basically this is your answer. So the A that you want, so the A you will take for the maximum volume of the tank is under root of 40 by 3. Okay, so that we can say 2 under root 10 by 3 also. Okay, this is also same thing. Okay, in meters, right? Okay, now let's go for next question. This is very good question. Okay, now what this question is saying is, a ladder starts slipping at t equal to 0. Find speed of end B when end A is moving at a speed of 2 meter per second and ladder makes an angle of 53 degree, okay, with the floor. So what is happening here is this ladder is with the support of wall and it starts sliding. So what is happening here is this point is going this side with VA velocity, let's say, and this point is coming down with VB velocity, let's say, okay. These are the velocities, okay. Now how to solve this, how to approach this question, that we're gonna see, okay, where VA is given 2 meter per second and at particular point he asks when the angle this is 53, okay, when he asked, like, but angle is also changing continuously, okay. So what can I say, this length of the ladder is constant, right? The length of the ladder is L, okay, and at any particular time I can assume this is as Y and this as X, okay, this is Y and this is X. So at any time I can say X square plus Y square is gonna be L square, right? This is what can I write always, okay. Now you differentiate this with respect to time. Why? Because we know dx by dt is gonna come here and that I can put it equal to VA, right? So what can I say here is you differentiate with respect to time, so you will get 2x dx by dt plus 2y dy by dt equal to L is constant, so that differentiation is 0, okay. Now 2 is also we can get cancel out, you take that side in denominator, so x into dx by dt, dx by dt is basically my VA, right, increment in A, dx by dt, right, plus y into dy by dt. So dy by dt I can say negative of VB because y is decreasing with time, so I can say that decrement in y is VB, so this is gonna be minus VB is equal to 0, okay. So from here what can I write is I can say VB is equals to x by y into VA, okay. And what is x by y? X by y is basically the cot 53, right? X by y, this is base upon perpendicular, right? So I can say cot 53 into VA, okay. So VB I want to calculate and VA value I know. What is the VA value? VA value I can say 2 meter per second, okay, and angle is 53, we said already. So cot 53 value is how much? I can say 3 by 4, okay, and this is VA is 2, so this is gonna be 3 by 2 meter per second, okay. That's all, okay. I hope you understood this thing, and yeah, okay, thank you.